Oh, man, I'm gonna
Okay, so notes today, we're gonna see how far we get, but we definitely need to get through this first piece, which we are now done with multiplying. So now we're gonna talk about dividing polynomials.
Let's go.
Okay, the reality is that when we're dealing with dividing polynomials, it can have multiple days as well, just like multiplying, right? They're the same in like their inverse properties. But we're not going to look at all the different situations with dividing because the majority of division properties fall into second year algebra. So the division that we're going to look at today is very, very, very basic. And it's also very simple. Okay? So our rule with division says that we are going to divide or reduce the coefficients and that we subtract the exponents exact same rules that we've had for however many days we've been talking about this, right? This isn't changing. And just like with multiplication, right, once we know that rule, we're just going to apply it multiple times within the same problem. So that same thing happens today. We're just going to apply that division rule multiple times within one problem. So maybe we have 12x to the 5th plus 8x to the 4th minus 10x to the 3rd and we are going to divide this all by a 2x squared. Right, so we have a trinomial divided by a monomial. All the division we're going to look at is going to be dividing by a monomial, so we'll have a polynomial divided by a monomial. Okay, when we divide, what we want to do is give this denominator, give this piece that we're dividing by, to each individual term. Right, just like when we were like solving for y, we divided, right, we would divide in each individual place. That's the same thing that we want to happen today. So we want to give this 2x squared to all three pieces. Is that a question, Josh?
Yeah, is that 12x?
2. I was just pointing the arrow right here.
No, for the first.
Oh, 12. 12x to the 5th. Yeah,
Oh,
sorry.
Just divide all of them by 2x.
Yeah, so then this is just like we were a week ago, and we're just going to divide each individual section with the rules we already know. So we'll ignore everything else, and we're just going to divide here. Okay, so 12 divided by 2 is 6.
X.
5 minus 2 is 3. And we'll get 6x to the 3rd. Yeah. Okay, then we'll ignore these pieces, right? We're just looking here in the middle.
4x to the second.
8 divided by 2 is 4. It was a positive 8. It's a positive 4. We'll subtract. 4 minus 2 is 2. And then we'll go to the last piece, right? Negative 10 divided by 2 is negative 5.
To 1.
3 minus 2 is 1. Do I need to write down that exponent of 1?
You
No,
can't.
you could, but you don't have to.
Yes, ma'am.
And so this would be our answer. None of these are like terms.
So wait, will we do more if they like term? Or
If there were like terms once we divided, that means that there were like terms in the original problem, and we could have combined them there. Okay, so if you see like terms in the end, you might want to double check and make sure that there are like terms in the beginning. That's just not very common.
So that's all we need to do.
Yeah,
That's simple. I wanna do more.
right, and it doesn't, again, right, this is the idea with exponents. This was the piece I was talking to you all week, right, that it's nice because the rule doesn't change. The rules don't change. Nothing gets more complicated, they maybe just take more time to do. The only piece that I would say is visually maybe a little bit complicated is that we have a variety of types of division signs, right? There are other ways that we can write division. So we could write a problem that says 30x to the 7th plus 24x to the 3rd. And we're going to divide that by 6x to the 3rd.
Say you want to do more. Huh?
Yes, Elijah?
I know I'm gonna do this, Josh. Are you allowed to rewrite it?
Absolutely. So my suggestion is, regardless of what this division sign looks like, do the same thing that we did on the first problem, and just take this 6x to the 3rd, right, and give it to each of the terms. I mean, realistically, we don't really write a division sign like this anymore. It kind of tends to show up here because when you get to second year algebra and you have to do long division with polynomials, you'll see this sign a little bit more often. Okay, so we're just sort of introducing it. It's not really a division sign we would use very often with this problem, but the idea is the same. 30 divided by 6 is 5.
That's
7 minus 3 is 4. So we'd have 5x to the 4th. 24 divided by 6 is 4. 3 minus 3 is 0. So do we even need to write it down? No, right? Because x to the 0 power is really just time multiplying by 1. So no need to write that. So that would be our answer.
Interesting.
Is this what our homework's gonna be like? Not really completely different.
Anybody think they know what we should do here? What do you think, Bailey?
You should still divide each of them by the 6 multiplication.
Right, so different division sign, but it's still division. So we're just going to take this and divide each of them.
Wait, are we allowed to have decimal?
Yes, as long as you don't round, right? No approximating.
Sweet.
But you don't need a decimal here. So 18 divided by 6 is
3 y to the 3rd.
5 minus 2 is 3. Okay, 10 over 6, right? If we do a decimal, we get a repeating decimal. But just reduce it, right? Leave it as a fraction,
5 variants.
right? 2 will go into each of them. So 10 divided by 2 is 5. 6 divided by 2 is 3.
Y.
Why is that y going to go in the top or in the bottom?
Top.
3 minus 2 is positive 1.
Top.
Positive exponents go in the numerator.
Gang.
So as long as you know your division rule, you're fine there. That's division.
That's all.
That's all there is for division. I have nothing else to add. The rest of division falls in second year algebra, so nothing we need to do there. Yes?
When I picked my schedule yesterday, I had a bunch of classes I didn't want to take. So like when we go to the scheduling meeting with our counselors, are we allowed to switch those?
Yes. If you need to say something when you meet with them, then you can.
I didn't have enough like credits, so I picked a choir class just to like get it.
Oh, to fill some things in. Yeah. Have that conversation when you meet with your counselor.
I have like 4 science.
No, we still have notes.
Oh.
perimeter?
Perimeter. We're
You
doing.
didn't say we were talking about shapes.
That's, I mean,
Geometry or anatomy?
The geometry or
Okay, so if we look at this problem,
Yeah. We'll try to.
okay, I'm sort of giving you some pre-info today, depending on what happens tomorrow. Even if we have a full day tomorrow, right, there's a pet session, so our class is still a little bit shorter. Okay, so we're gonna be dealing with
I
polynomials.
have a question.
Yes.
If we have a 2-hour delay tomorrow, are we still gonna have the pep session?
I have no idea.
She said that just go to class on Dylan.
Okay, perimeter. If we are dealing with polynomials and perimeter, that means we need to know what perimeter is to start with. So remember, way back when at the start of first trimester, we reviewed in some of those problems what perimeter was. Right? Elijah, what does perimeter tell us to do?
Add side to side to side, or to side.
Right? We're gonna add up all the sides. Okay, now that we know how to add with polynomials, we can now introduce the idea that maybe these side lengths aren't pure numbers, but maybe they're things that include unknowns or they include variables. So maybe we have side lengths of 3x plus 4, 5x minus 1, and 2x plus 5.
Did we do this already?
No. It's moving for me.
Oh, I think
I think not.
Okay, so if we want to find the perimeter of this triangle, what would we need to do?
Oh no.
What does perimeter tell us to do, Elijah? Add both sides. And good news, we know how to add with polynomials. So we can just take
You just put them in the.
3x plus 4, and we can add that to 2x plus 5. And we can add that to a 5x minus 1.
and wait, we don't
Hang on. This is already stacked in a format where we have the matching terms lined up. Okay, if it was a situation where these weren't all matching terms, right, you would need to shift them to get matching terms together. Okay, so if we add here, right, 3x plus 2x is 5x, 5x plus 5x is 10x, 4 plus 5 is 9.
Minus 1 is
9 minus 1 is positive 8, right? It's a positive 8. So that's where that plus 8 comes from. So we would say the perimeter of this triangle is a 10x plus 8.
That's it.
That's it.
That's
Why is stuff so easy to do?
For real, I'm getting suspicious.
You're not going to be as happy with me tomorrow.
Oh yeah. Alright, I'm not going to school tomorrow.
neither am I.
I'm gonna come for
Stay at
and
home.
sit right outside the door.
I'm gonna eat.
Okay, so let's say this is what we have.
Oh wait, we know the information already.
Right, this provides us with all the information we need. It's very similar to when we're given length and width of any rectangle. Now, assuming my rectangle is perfect and we know that it's actually a rectangle, right? If we want to find the perimeter, we would add up all the sides. How many sides does a rectangle have?
4.
4, but we're only given 2 measurements.
Just multiply by
Okay,
2.
so we would need, right. Okay, so class, listen here. We need to fill in these pieces. Okay, because Josh said, well, we could just multiply them by 2, which is a true statement. Okay, we could also go, there's multiple perimeter formulas, right? Twice the length plus twice the width. We could do 2 times the length plus the width. We could do a length plus a width plus a length plus a width. Okay, so whichever formula you sort of prefer is fine.
I know it.
Okay, most of my students prefer to just fill in the other measurements.
Right.
I didn't have to write anything.
I'm getting smarter by the day.
Right, so we can write all 4 of them.
Then,
So we'll say 5 plus 2 plus 5 plus 2 gives us 14.
that 14x minus.
Look how you guys are like crazy today. Okay, then we'll do -2 plus 1 plus -2 plus 1 will give us a -2.
Go.
So our perimeter of this rectangle will be a 14x minus 2. Are we okay with all these notes
Yeah,
today?
we're good.
Yes.
Questions over any of them?
Nope.
Nope.
This is more.
So here's